Hello class, this lesson is 4-9 in your textbook and it's titled How to Perform Congruence Transformations. So we've talked about transformations a few sessions ago, and what those are different movements that you can perform on some sort of image, and it's going to keep the same shape. It's just going to maybe be in a different location, or it might be turned a little bit. Those three types were translation, reflection, and rotation. And so we worked a little bit about it with before, but now we're really going to get specific so that we don't make any mistakes when we actually perform these operations. So let's review what a translation is. Translation is an operation that moves every point of a figure the same distance in the same direction. So if I have a figure drawn, it could be a triangle, it could be a star, whatever it is, and I take all of those points, I'm going to move them all the same distance in the same direction. So for instance, if I want to move everything to the right 5 units and then down 3 units, I got to do that for every single point. The way that we're going to do that is you change every point. If it's already x comma y, we're going to change it to x plus some number, or it could be minus some number, and then y plus some number or minus a different number. Okay, so we're moving a figure. The A stands for how many units. It's either going left or right. If it's left, it's going to be negative. If it's right, it's going to be positive. And the B that we're adding to the Y is how many units. It's either going to go up, which is positive, or down, which is negative. So I have an example for us. Let's go ahead and test this out. Figure ABCD has vertices of the following. A is -4, 3, B is -2, 4, C is -1, 1, and D is -3, 1. It wants us to sketch this image and then also sketch its translation. And the translation is adding 5 to the x and subtracting 2 to the y. So this means it's going to go right 5 and down 2. So I think that what I should do first is just sketch that image, A, B, C, D. So let's go ahead and do that. A is -4, 3. B is -2, up 4. C is -1, up 1. And D is -3, up 1. Whenever it gives you an image and it tells you the order that it's listed, that's the order that you need to connect the dots, because sometimes the images might get more complicated and you just need to make sure that you're connecting them in the proper order and not connecting like A to C, for instance. That would be wrong. All right. So that's what my image looks like right there. And then it wants us to do the translation. So in order to do this, I'm going to list my points right here, my original points. So -2, 4, -1, 1, and -3, 1. And then I'm going to change each of these by adding 5 to the x and subtracting 2 from the y. So -4 plus 5 is +1, and 3 minus 2 is 1 as well. Okay. -2 plus 5 is 3, and 4 minus 2 is 2. -1 plus 5 is 4, and 1 minus 2 is now -1. For the final point, -3 plus 5 is +2. And 1 minus 2 is -1 as well. Okay, so this is kind of like my A prime and my B prime and my C prime and my D prime. So it's changed from this transformation. So let's go ahead and graph those now. So A prime is 1, 1. B prime is 3, up 2. C prime is 4, down -1. And D prime is 2, down -1. And then I can connect all these dots in the same order. And now I have successfully translated the first image into a different position for the second image. And this is all that you might be asked to do for translations in the book. Okay. Let's move on to the second type of transformation. It's a reflection. And let's just remember that a reflection uses some line of reflection to create a mirror image of the original figure. So we're not simply just moving the image, but we're reflecting it. And in this book, we're only going to be reflecting across either the x-axis or the y-axis. So that's always going to be kind of where our mirror is. And I also have some little kind of codes for us for what those points are going to change into. So if you are going to reflect points of an image across the x-axis, the only thing you need to change is to multiply the y value by -1. So if you have a point, x comma y, the x is going to stay the same, but the y, you're going to take the negative version of it. If it's already negative, two negatives will make a positive. And this is very similar to if you reflect a point or an image across the y-axis. You're going to multiply the x value by -1. So if you have x comma y, it's going to turn to -x comma positive y. Okay, so I have an example based on this one as well. This I'm asked to reflect the following image across the x-axis. So I already have this image right here. It's kind of like a little zigzag line, and it's wanting me to reflect it across this x-axis right here. So take a moment and just try to draw this a little bit. I've also listed the points for all of those vertices or the endpoints of these little line segments, and they are -1, 0, 1, 2, 5, 0, -1, 2, and 1, 4. So just like I did before, if I have a point x, y, I'm going to kind of plug it into my little cheat sheet, and I am reflecting it across the x-axis. So this is where the only thing I need to do is multiply the y value by -1. So this is going to be x, -y. So my first point is going to be -1, 0. That's going to stay the same. The next one is 1, now it's -2. The third point is 5, 0. The fourth point is -1, -2. And the fifth point is 1, -4. So let's go ahead and plot these points, and then we can connect them. So let's see here. -1, 0 is already there. Also 1, -2. 5, 0 is already plotted. -1 down -2, and also 1 down -4. Now let's just go ahead and connect those dots. You should be able to draw a perfect reflection of this top image. And look at that. I have an arrow. Pretty awesome. Okay, so this is something else that you might be asked to do in today's lesson. The final thing that we're going to talk about is rotation. Okay, let's remind ourselves that a rotation is turning a figure about a fixed point, okay, or around a fixed point, called the center of rotation. So some things that we're going to keep in mind in this lesson is that we will only be rotating around the origin. That's always going to be that point that we are kind of turning an image around. And we can turn it two directions. We can turn it clockwise or counterclockwise. The third thing I want us to remember is that when you perform a rotation, it's going to preserve the distance from the origin. So if I have a point, and let me just draw a little sketch for you right here. If I have a point that's over here, and I'm going to rotate it 90 degrees around the origin, whatever the distance is from this first point to the origin should be the exact same distance it is when it's rotated. Okay? So I'm going to leave us with this example. It's kind of a two-parter. We're asked to graph line segment AB and line segment CD. And then we're asked, is CD a rotation of AB around the origin? If so, give the angle and direction of rotation. So I'm going to just cover up this first one just so that we don't have too much to look at. We're asked to make these two line segments, and I'm given the points right here. A is -3, 1, B is -1, 3, C is 1, 3, and D is 3, 1. So let's go ahead and draw these and label them. So -3 up 1, this is A, and -1 up 3 is B. Okay, I'm going to take my ruler and I'm going to connect that. Okay, and then C is 1 up 3, and D is 3 up 1. Okay, so let's ask ourselves, looking at this now, is it a rotation around the origin? Again, the origin's right here. And so a way that I can think about this is looking at the distance of each point and see if it's preserving its distance when it's being rotated. So from A back to the origin, it's going diagonal across 3 of those squares, and it should match with C, and C is also going diagonal 3 of those squares. So far it looks like it's good. B from the origin, the distance right here, is 3 squares across, and D is also 3 squares across. So awesome, it does look like it's a rotation. What direction would you say it's going? If it's starting here at AB and it's going to CD, that is going clockwise. So I'm saying that it is a rotation in the clockwise direction, and the angle, if you look right here, is 90 degrees from this line to this line right here, the rotation. So it is rotating 90 degrees clockwise. Awesome. Okay, let's go ahead. I was kind of giving you a preview of this last one. So the points for this last one are for A, 0, 1, B is 1, 3, C is -1, 1, and D is -3, 2. Okay, so let's go ahead and plot our first segment, AB. So 0 up 1, that's our A, and B is 1 up 3. Okay, let's connect these. There we go. And then let's go ahead and do CD. C starts at -1 up 1, and D is at -3 up 2. Okay. I'm looking here, and it kind of looks like, oh, maybe it is a rotation just going in the counterclockwise direction. So let's just check out those distances and see if the distances were preserved. So A going to the origin, and then C going to the origin, those don't necessarily match. One is going across a square, whereas the other one is just going straight down 1 unit. But let's just check out B and D. B is going diagonally through 3 cubes or squares, but D is going across 6 squares through the diagonal. So definitely this is not a rotation, and it's pretty clear to see that. So that's all that we're doing today. I hope that it has been informative for you, and if you're confused with anything, just come to class with any questions, and I'm definitely going to help you out.